Hello students, welcome back. So welcome to Shifan Global Academy online classes. Okay, so in the previous video we have started amines. Okay, we have started amines. We are discussing amines. Amines are derivative of ammonia. How do we get a amines? So see here, this is a ammonia molecular formula. Ammonia has one nitrogen, three hydrogens, and one lone pair of electron. Okay. By the replacement of one or two or three hydrogen, we get different type of amines. Okay. In the previous class, we have discussed about type of amines. It's a primary amine, a secondary amine, and tertiary amine. Okay. So first, the classification of amine we have discussed. First one is a primary amine. Okay. Secondary amine and tertiary amines. Okay. How do we get a primary amine? So one of hydrogen is replaced by ethyl, methyl, or any other alkyl group or aryl group. We get primary amine. Okay. Take an example NH2. Okay. Out of three hydrogen, one of hydrogen is replaced by the R group. R group may be it a alkyl or aryl group. Alkyl means ethyl, methyl, propyl, butyl, pentyl. So these are called alkyl. And aryl means benzene based compounds. Okay, so benzene based compounds are called aromatic amines and alkyl, butyl, pentyl. These are called aliphatic amines. Okay, so then secondary amine. How do we get a secondary amine? By the replacement of two hydrogen with alkyl or aryl group. Two alkyl or aryl group, we get secondary amine. See here R NH R dash. Okay, so this is an example for secondary amine. And tertiary amine, all the three hydrogens atoms are replaced by three alkyl group, we get tertiary amine. See here R N R R. Okay, so these are examples for primary, secondary, and tertiary amine. And we have discussed about IUPAC names. Okay, nomenclature of IUPAC names, how to give the IUPAC name for amines. Okay, so what is the reason? So I'm going to take an example here. CH3, CH2, NH2. Okay, so this is a primary amine. Example for primary amine. Why? Because here out of three hydrogen in ammonia, only one hydrogen is replaced by the ethyl group. Okay, how to give the IUPAC name for this compound? CH3, CH2. There are two carbon atoms are present in this system. So if a two carbon means it is a carbon has a single bond, so it is a ethane plus functional group is amine. Okay, ethane plus amine. Okay, then how to write the name? Cut the E and join the name. So it's a ethanamine. Okay, so this is the IUPAC name for this compound. Okay, so these are discussed about, these concepts are discussed about in the previous classes, and now I'm going to discuss about the next part called preparation of amines. Okay, so amines are prepared by various methods. Okay, so here there are more than 5 methods is there. So I'm going to discuss about one by one. Okay, let's start preparation. Okay, preparation of amines. Okay, so first method we are going to discuss about reduction of nitro compounds. First method is reduction of nitro compounds. Reduction of nitro compounds. What are the nitro compounds? See here NO2. Okay, NO2 is called a nitro group. Okay, if NO2 group is attached to alkanes, for example CH3, which means it's a nitromethane. Okay, it is a nitromethane. If you reduce the nitro group means we get primary amine. So from the name reduction, what do you mean by reduction? Reduction means addition of hydrogen or removal of oxygen is called reduction. Okay, so here we are remove the oxygen and instead of oxygen we are going to add hydrogen. See here I must write in generally CH3NO2. If reduction process is carried out, what is the product? Removal of oxygen and we are adding hydrogen CH3 and NH2. This is our product. Okay. So what happened? The two oxygen are removed from here and two hydrogen added here. So see here, this is a primary amine. Okay. So this is called a reduction of nitro groups. Okay. When we are reduce the nitro group, we get amine is the product. What kind of amine? This one is a primary amine. Why? Because out of NH3, one hydrogen is replaced by one alkyl group. Okay. So that this is a primary amine type. So from this type, we can synthesize primary amine. Okay. Nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel, palladium or platinum, and also by reduction with the metals in acid medium. Okay. Then nitroalkanes. Okay. Nitroalkanes can also be similarly reduced to the corresponding alkanes. See here, the nitro groups. Okay, the nitro groups N wood. I am taking generally N or N wood. The nitro groups are generally reduced by passing hydrogen gas. Okay, addition of hydrogen gas. What do you mean by addition of hydrogen? Addition of hydrogen is known as hydrogenation reaction. Okay, we are carrying out here hydrogenation reaction. For hydrogenation reaction, we have to add some catalyst. We have to add catalyst. What is the purpose of catalyst? Catalyst is which induce the rate of the reaction. Okay, so what is the purpose? It induce the rate of the reaction. Which means if a reaction happen in 20 hours means if catalyst induce the rate of the reaction, we get a product within 20 minutes. Okay, this is the purpose of catalyst. And catalyst they provide surface area for hydrogen. So here we are using platinum, palladium, nickel based catalyst. Okay, so these are acting as a catalyst. These metals are acting as a hydrogenation catalyst. See here, I am going to take an example here. What is the compound name? This is a nitrobenzene. This is called a nitrobenzene. Okay, this is called a nitrobenzene. When nitrobenzene is treated with H2 gas in the presence of palladium based catalyst. Okay, out of three metals, we can use any one as a catalyst. Okay, so here I am using palladium as a catalyst, and hydrogen gas will be added here. And here ethanol as a solvent. Ethanol as a acting as a solvent. What is the product we get? Here we get NH2. Okay, this is a amine. This is a primary amine. What is the name for this compound? This is called aniline. Okay, the product name is aniline. Aniline. What is the IUPAC name for this compound? This compound is a benzene amine. Okay, benzene plus amine, benzenamine. We have to remove E from the name, so we get benzenamine. Benzenamine. Okay, so this is the final product of this reaction, and this is also primary amine. Why? Because out of NH3, one hydrogen is replaced by benzene. Okay, so this is a primary amine type. Primary amine. See here, and this is also aromatic amine. Okay, because benzene based compound, so it is a aromatic amine. So from this method, we can easily prepare aromatic amine. Okay, and same method we can also prepare aliphatic amines like methanamine, ethanamine, butanamine. We can prepare those compounds also. Okay, see here. I'm going to write the next one. CH3NO2. What is the name? It is called nitromethane. Nitromethane. This is the IUPAC name for this compound. When nitromethane undergo hydrogenation reaction H2 in the presence of nickel based catalyst or palladium based catalyst or platinum based catalyst, okay, we get in the presence of ethanol as a solvent. What will happen? The NO2 group is reduced. Okay, so CH3 and NH2 is the product, primary amine. Okay, so this is a primary amine product we get. Okay, so when hydrogenation reaction, addition of hydrogen, okay, when hydrogen reaction takes place, we get as a NO2, okay, NO2 is going to reduce to and we get NH2 is the product. Okay, so the nitromethane now it's converted into methanamine, methanol. So it's a primary process. So this is the first process. Okay, this is the first method of preparation, reduction of nitro compounds. Okay, then also we can use, okay, instead of platinum palladium catalyst, we can use also tin plus hydrochloric acid. Okay, we can use the catalyst is different here. This method also used to reduce the nitro. Okay, tin SN plus HCl. Okay, this can also use as a reducing agent. It can be able to reduce the NO2 group. Okay, then what is the product? We get product like this NH2. Again, we get a primary amine. Okay, but we can also use iron HCl, iron star and HCl. Okay, this also catalyzes the reaction. And iron it is used in the industrial purpose to prepare the amine. Okay, and also it's a very important process. Next process we are going to discuss about ammonolysis of alkyl halides. It's one of the very important ammonolysis of the alkyl halide compounds. Next process, second preparation, ammonolysis, second reaction, second process. Ammonolysis. Okay, ammonolysis of alkyl halides. Alkyl halides. Okay. See here from this name, what do you mean by ammonolysis? Addition of ammonia. Okay, addition of ammonia is called ammonolysis. Okay, then alkyl halide. From the name, what is alkyl group? CH3. Okay, it's another example for alkyl. Methyl ethyl propyl. And halides means it's a chloro bromo iodide. These are called halides. Okay, maybe it's a one of the X group. X group is a halides, bromo chloro iodide. Anything. Okay, so when ammonia it's reacted with the alkyl halide. Okay, it gives the primary amine. This process is called ammonolysis. Okay, let's see here. Through mechanism, I will explain the reaction. Okay, through mechanism, I will explain it. Just watch it. Take a reactant. Okay, ammonia. Okay, because it is an ammonolysis reaction, we have to add ammonia. Ammonia is react with an alkyl halide. Alkyl halide we have to take anyone. Here I am to take methyl group. CH3 halides means here we take Cl. Okay, it is a chloromethane. Okay. So this is an example for alkyl halide. See here, the ammonia is acting as a nucleophile. Nucleophile means it can able to donate the electron to the electron deficient species. Okay. See here, these two in this compound, okay, chloromethane. There are two species in that. One is methyl and the another one is chloro. The carbon here is the carbon and here is chlorine. Okay. Carbon has less electronegativity. Okay, carbon has less electronegativity than chlorine. So chlorine can pull the electron. Okay, in this bond is made up of two electrons, one electron from carbon and one electron from chlorine. Okay, they create a one bond. Okay, but chlorine has a more electronegativity, so that the chlorine can obstruct the electron or pull the electron towards itself. Okay, partially the bond, the two electrons are the carbon electron is moved towards chlorine, near to chlorine, so that the chlorine bears partial negative charge. Okay, in chemistry we mention if an atom loses its electron means we mention is a positive charge. Okay, positive indicates loss of electron. If it is a gain of electron or extra electron means it is called negative charge. Okay, in this bond, chlorine gained electron of carbon from carbon. Okay, chlorine gained electron from carbon Okay, but the bond is not completely break. Okay, so it has a partial negative charge. See here, this carbon is lost its electron partially, so it is a partial positive charge. Among the two species, chlorine is more electro electron rich. Okay, but because it already have a negative charge means it's a electron rich species, and methane it is an electron deficient species, but because it has a positive charge, so that it is a electron deficient species. Now the ammonium, it acting as a nucleophile. Nucleophile means they are electron donor species. Nucleophiles means they are electron donor species. Okay, nucleophile. In ammonia, nitrogen has a two lone pair of electron. It has a two lone pair of electron. Nitrogen is going to donate electron to the deficient species. Among the two, which one is electron deficient? Methyl. Methyl is a carbon is electron deficient. So the nitrogen is going to donate the electron to the carbon. Okay. When nitrogen carbon can form a new bond means the carbon valence will be increases. Usually the carbon valence is 4. Carbon can make 4 bonds itself. Okay. But one new bond is created from nitrogen to carbon means the valency of carbon will be increases to 5. Okay. So that one of Cl. Okay. When new bond created here, the Cl is eliminated from here. Okay. The Cl move from here. Then what we get? CH3, CH3, NH, CH3, NH3. Okay. Then Cl is moved out. Okay. So see here, nitrogen can it donates its electron to the deficient carbon. Carbon here. Okay. So here nitrogen it lost its electron. Okay, nitrogen என்ன பண்ணிருக்கு? It's lost its electron. So it bears positive charge. It bears positive charge. Okay. So chlorine gained the extra electron. How it eliminate Cl minus. Okay, Cl minus. So here Cl minus is there. Okay, Cl minus, there is no bond between nitrogen and Cl. Okay, it is just a attractive electrostatic attraction. Okay, why? Because it has a positive charge and it has a negative charge. Just the attraction. There is no bond between nitrogen and chlorine. Okay, so CH3, NH3, Cl. Okay, for my convenience, I am writing the NH3 like this. NH2 H. Okay, for my convenience, I am writing this group like this. Okay, so it is a reaction intermediate. Okay, it is an intermediate. Okay, it is a reaction intermediate. So it is an intermediate. It's called a substituted ammonium salt. Okay, it is a substituted ammonium salt. Okay, this is called a substituted ammonium salt. Okay, this is a reaction intermediate. And the next step, okay, and the next step, I'm writing here. And the next step, we are adding the base NaOH, sodium hydroxide. When sodium hydroxide it start dissociate, it produce sodium plus Na plus and OH minus. Okay, it produce Na plus and OH minus. See here in this intermediate, the nitrogen is electron deficient because it has a positive charge, so it is a electron deficient species. So the nitrogen is more electron negative than hydrogen. Hydrogen is a very weak, so it can abstract the electron from hydrogen. It takes the electron from hydrogen, and the hydrogen is leave from the place like H plus. Okay, it leave from like a H plus. Okay, the H plus and OH minus, the both are combined together to form a water molecule H2O. It leave from H2O. Okay, and remaining is Na plus. Okay, the Na plus and Cl both are combined together to form Na plus. NaCl. Sorry, NaCl. Okay, and the remaining terms are see here CH3. Okay, CH3 and NH2. NH2. It has a lone pair electron. See here, this is the primary amine or not? Yes, we are prepared primary amine. It's called a methanamine. Okay, methanamine. Okay, it is called a methanamine. It's a primary amine. Okay, so from this process we can synthesis. In first step we can synthesis what? Amine. Okay, it is a primary amine. Okay, one more time I will explain it here. Why? Because it's very basic step. Okay, first initially we take ammonia. Okay, ammonia we take the starting material ammonia and alkyl halide. Okay, in alkyl halide carbon is electron deficient species, or because chlorine has more electronegative, it take the electron from carbon. Okay, so it becomes partial positive and it has a partial negative. When nitrogen is a nucleophile, okay, ammonia is a nucleophile, it's going to donate the electron to deficient carbon. Okay, if a new bond created between nitrogen and carbon, the Cl is leave from the space. Okay, we get a intermediate like this. Okay, and we are adding NaOH, sodium hydroxide. The sodium hydroxide start dissociate, it produce Na plus and OH minus. The OH minus it attached with the hydrogen H plus, it produce H2 water molecule, and the Na and Cl both are combined together to form NaCl and leave from the space. Remaining terms are CH3 and H2. Okay, so we prepared here methanamine. Okay, so this is a primary amine. Okay, the reaction is not end here. Okay, it's going to continue. Okay, so in the last step what we have prepared? We have prepared we have prepared CH3 NH2. We have prepared the primary amine. Yes or no? Yes. This is a primary amine. We have prepared primary amine. Now, the primary amine is going to react one more molecule of alkyl halide, CH3Cl. Okay, it's going to react with one more molecule. See here, it's a dou positive charge. Cl is a dou negative charge. When nitrogen has a lone pair of electron, it's acting as a nucleophile. It's going to donate the electron to the deficient carbon, and Cl is leave from the space. Okay, then we form a one stable intermediate here. The intermediate structure is CH3. See here, CH3 and NH. For my convenience, I am writing the NH2 like this: NH, H. Okay, then CH3 another bond. Okay, then Cl, it's just an interaction. Okay, nitrogen it's lost it electron, so it bears it gain positive charge. Okay, the Cl is just an interaction only, electrostatic attraction only. There is no bond between the compounds. Okay, next step we are going to add sodium hydroxide, NaOH. They dissociate means they produce Na plus and OH minus ions. Okay, so the nitrogen is electron deficient. It's going to abstract the electron from hydrogen, and the hydrogen is eliminated out here. It produces H plus ion. The H plus ion and the OH minus both are combined together to form water molecule. Okay, then remaining Na plus, the Na plus and Cl minus both are combined together to form NaCl. And the remaining species is CH3 NH CH3. So this is the final product. See here, in ammonia two hydrogens are replaced here. Okay, one is CH3 and another one is another CH3. Okay, so this is a secondary amine. This is an example for secondary amine. Okay, so from this method we can also prepare secondary amine. Okay, if we continue the reaction, means we get secondary amine also. Okay, so what is the name for this compound? High impact name for this compound? See here, in both sides, amine, okay, nitrogen. In nitrogen is both sides. Two carbons are present here. One here, one and here one. So how to write the name for secondary amines? We can write the name like this. Okay. So methanamine. Okay. N methanamine. Okay. N methanamine is the IUPAC name for this compound. Methanamine. N-methyl methenamine is the IUPAC name for this compound. Okay, still the reaction is not end here, it's going to another one cycle. See here. So what we get in the last step, CH3 NHCH3. Okay, we get secondary amine. We get secondary amine is the product. Okay, we get the secondary amine is the product. Next step, again we have to add one more molecule of alkyl halide, CH3 Cl. Okay, same step again. The nitrogen is going to donate electron here. The Cl leaves from the space. What we get? CH3 N. My convenience I am writing like this. NH. Already one CH3 is there. CH3 and new CH3 and Cl negative and positive for N. Okay, so now I'm going to, this is intermediate. Now I'm going to add sodium hydroxide. Okay, so sodium has a positive, OH has a negative charge. Nitrogen abstract the electron and it leaves the H plus. And these two are produced water molecule. These two are produced NaCl. The remaining terms are CH3 N CH3 CH3. See here, in ammonia all the three hydrogen atoms are replaced by three different methyl groups. Okay, three methyl groups. Okay, so all are methyl groups. So this is an example for tertiary amine. Okay, this is an example for tertiary amine. Okay, so from this ammonolysis of alkyl halide, we can prepare primary amine and secondary amine and tertiary amine. We can prepare primary, secondary and tertiary. So among the three, which one is a major product? Means primary amine is the major product. Why? Because if you take a because initial step is a primary amine only. Okay, from the primary amine itself, we can prepare secondary and tertiary amine. So primary amine is the major product. Okay. Then reactivity in ammonolysis, we are going to next discuss about the reactivity order. Reactivity order of alkyl halides. Reactivity order. Okay. In reactivity order, it is based on, we can write the reactivity order based on the alkyl halides. Okay. Alkyl halides, I am taking here, maybe it's an R iodide, R bromide and R chloride. Okay, R iodide and R bromide and R chloride. Based on these three, okay, the rate of the reaction will be different. Okay, so the reactivity order Ri. Okay, see here, I'm going to discuss the reactivity order. First, alkyl iodide. Okay, here I am taking some methyl iodide as an example. Okay, methyl iodide and methyl iodide and methyl bromide and methyl chloride. Okay, so methyl chloride. See here, the reactivity. Okay, the reactivity order, it depends on the three factors. Okay, the reactivity order, it depends on the three factors. The first factor, size of the halides. Okay, why? Because see here, in all the three compounds, alkyl is same. Alkyl compound, alkyl species are same. See here, it's a methyl. Alkyl species are same, but the halides are different. Okay, halides are different. So first one is a alkyl halide. So first it's a size of the halides, and second one is a bond length. Third factor, bond dissociation energy. Okay, bond dissociation energy. Okay, and see here, note here one important point: the bond length and the bond strength both are indirectly proportional. Okay, so the bond length and it's indirectly proportional to the bond strength. Okay, bond length and bond strength both are indirectly proportional. If bond length is increases, the bond strength will be decreases. If bond length decreases, the bond strength will be increases. Why? Because both are indirectly proportional. Okay, so you see here in first methyl iodide, the size of the iodine will be high. Why? Because in halogen species in periodic table, fluorine, chlorine, bromine, iodine. Okay, in top to down, if you move from the periodic table in top to down along the group, size of the elements will be increases. Okay, see here fluorine is like this, and chlorine, bromine, iodine. Okay, top to down, the size of the elements will be increases. So that in methyl iodide, the size of the iodine will be increases. The size of the iodine will be very high. If size will be increases, the distance between the carbon, okay, the distance between the carbon and the halide will be also increases. If distance increases, the bond length also increases. Okay, if bond length increases, the bond strength will be decreases. Why the bond strength is decreases? Why? Because the attractive force between two atoms. See here, the attraction force. If the bond length will be high, means the attractive force between two atoms is very less. Okay, so we can spend less amount of bond dissociation energy. Okay, what do you mean by bond dissociation energy? The amount of energy is required to break the bond. Okay, it's called a bond dissociation energy. See here, it is a weak bond because the distance between two atoms is very high, so it is a very weak bond. So we can spend less amount of energy, means the bond easily dissociate. The bond is easily dissociate. Okay, so here bond length is very high, so bond length is increases. So bond strength will be decreases. Okay, so dissociation energy is very less. But in this case of methyl bromide, see here bond length is very high, but comparatively here the size of methyl bromide is very small. Okay, the bond length is very small here, and if a bond length is small, means the bond strength will be increases. Okay, bond length is decreases, at the same time the bond strength will be increases. If the bond strength will be increases, the dissociation energy, the bond dissociation energy is also increases. Bond dissociation energy increases. Okay, so we have to spend lot of energy to break the bond. Next is methyl chloride. In methyl chloride, the size of the chlorine is very small. So the distance, the bond distance between methyl and chlorine also very small. Okay. So here is bond length is very small. Okay. The bond length again decreasing. If bond length is decreasing, means the bond strength also increases continuously. It increases. So the bond dissociation energy also increases. Okay. So the reactivity. Okay. So நான் உங்களுக்கு ஒரு டவுட் வரலாம், ஏன் இதை வந்து நீங்க டிஸ்கஸ் பண்ணிட்டு இருக்கீங்க, இங்க ஏன் வந்து நம்ம இதை வந்து பார்த்துட்டு இருக்கோம், எதுக்காக இதை டிஸ்கஸ் பண்றீங்க அப்படின்னா, see here நம்ம மெக்கானிசத்துல என்ன பார்த்தோம், what is in mechanism, first step the ammonia. Okay, in first step ammonia and methyl iodide. I am writing C here, methyl bromide and methyl chloride. Okay, so I am taking three different alkyl halides. Okay, if ammonia going to approach the chlorine, okay, carbon, in the first methyl iodide, means the bond dissociation energy is very less. Okay, the bond can easily break. Okay, the bond can easily break with less amount of energy. So the reaction, the next step, the intermediate can easily form within few minutes. Okay, but in this case the bond strength is little high, so it takes some more time to break the bond. It takes some time. And see here the bond strength is very strong, so the rate of the reaction is very slow here. Okay, here the rate of the reaction will be very fast, and here rate of the reaction is very slow, and here is very slow. Okay, why? Because the bond strength is increases, so that the bond dissociation energy will be decreases. Okay, okay student, thank you so much. Okay, so we are in this class we discussed two preparation of nitro compounds. In my next class I am going to discuss about remaining two. Okay, remaining two and one more naming reaction is there. I will discuss the next class. Okay, thank you so much. Study well.